Yeah. All right. Yeah. How about the chemistry of tie-dye? How about that? All right. Hey, so here's the plan, and I've already told them this, but we are going to have a test, and I'll say it one more time. We're having a test Thursday over Big Bang Theory, or Origins of the Universe. It's not just Big Bang Theory, but the Origins of the Universe study guide. Make sure you have that done and ready to use. You really need to have it done by Wednesday because you're going to check it Wednesday. At some point Wednesday, you need to check it with the Google form, make sure all your answers are right, okay? Then you can also use these notes on the test on Wednesday because there will be some questions about the chemistry behind tie-dye. This is officially tie-dye week. Now for you guys here at school, we're going to go over the chemistry that we're going to do tomorrow in class. But for the kids at home, they're going to have the option of doing tie-dye with bleach. So kind of like a reverse process of what we're going to do. And we're going to talk about, though, the main process that we use here at school. And then we're going to throw in some of the bleach tie-dye. Okay, but here's the chemistry of tie-dye, though. Here's some facts you need to know. Okay, first of all, you need to know and write down that dyes have been used for hundreds of years. Okay? Dyes have been used for hundreds of years.
Oh my God.
I know how far back it is, but I know it's Egyptians.
Yes, Egyptian. Well, and yeah, and even like, I think the ancient Japanese were the first ones credited with learning how to use dyes and using fabric and tying it off to create designs and patterns. So the ancient Japanese technique was called shibori. The ancient Japanese technique of tie-dye was called shibori. And that word means resist dyeing. Mhm. All right. And today the plan is to just talk about what we're going to do from start to finish. Tomorrow in class and then going all the way through Wednesday. Have any of you ever tie-dyed like at a birthday party or something? Yeah. Okay. So a couple of us. All right. The chemical process is what we're going to talk about, and it's pretty simple and straightforward. Okay. The first thing that we are going to do tomorrow, and the first thing that you typically do when you're tie-dyeing something, is you pre-soak it. So tomorrow when you get here, step one is we're going to pre-soak in a soda ash. Pre-soak in soda ash. Now the scientific name for soda ash, and I can't remember if it's sodium bicarbonate or sodium just carbonate, but it's sodium bicarbonate or sodium carbonate. You don't need to know that, but just know it's like a high-powered baking soda. Now we use baking soda. You can use baking soda at home like for cooking, or you can stick it in your fridge to absorb odors, but it's a very basic powder. If I say that something is a very basic powder, what does that mean? What do you, go ahead, Eddie.
Yeah, it's opposite of an acid.
Yeah, very good. It's the opposite of an acid, right? It can still do damage to tissue, right? Now, we are not necessarily going to wear goggles tomorrow, but we are going to wear gloves because this basic soda ash solution is real slippery and slimy feeling, just like bleach is, and it'll irritate your skin just like bleach will. So we'll use gloves tomorrow while we're working with the soda ash. So we're going to pre-soak. Now here's why, okay? The reason why we do that pre-soak in soda ash is because it helps raise the pH. Okay. Appreciate it. Thanks. That'll work. Thanks. All right. So it helps raise the pH of the shirt, causing the little hydrogen ions in the cellulose fibers to stand out. So it raises the pH. So if you say you're raising the pH, that means you're probably going to have a number above what? What's the scale of acids to bases? Above a 7, yeah. If you go above a 7 on the pH scale, you're saying that that solution is basic. If you go below a 7, it's acidic. So we're trying to raise the pH because all those little hydrogen ions want to stand up like hooks. They're going to stand up like this, and they're going to wait for color to come across and bond, okay? But that's all the soda ash does, is it gets it ready. It gets all those cellulose fibers. Cellulose is the complex carbohydrate that you find in cotton, right? Which is why tomorrow you need to make sure that your shirt or your socks, whatever it is that you bring, it's got a really good cotton content. Like you want a high percentage of cotton. It doesn't have to be 100% cotton, but above 50 or 60% would be good. Okay. All right. So we good? All right. Number 2, the next step is you crumple the shirt into a pattern. We're going to squeeze out all that juice over the bucket. We're going to wring it out really well. And then we're going to take it to a table. We're going to lay it out flat, and then we're going to crumple it. You can twist it and turn it into like a swirl. You can do bullseye patterns on it. You can do just where you do a scrunch, where you just scrunch it up. You can do a twisted pattern to where it'll have like lines running like this.
Am I able to make it look like a painting I did in kindergarten?
I don't know. I've had kids that try different things. Sometimes they work out awesome and it's incredible. Other times it just looks like somebody died on it. So it's really kind of, yeah, so maybe they did. All right, but if you want to look up like a pattern that you have something specific in mind, you can look up on Google and it'll tell you kind of how to do a tie-dye pattern. I'll show you just some basic ones that are real simple and they still look cool. But we'll go over that tomorrow. Now, let me ask you this. If you're crumpling the shirt into a pattern, is that an example of a physical or a chemical change? Physical, right? Why?
It's still a shirt.
Still a shirt. It's still just a cotton shirt that's got a base on it. And honestly, we really haven't even changed much about the shirt chemically. All we've done is kind of put those hydrogen ions on alert, okay? So, all right, so we've crumpled the shirt into a pattern. We'll rubber band it really well. Okay, and then we're going to take it over to a different table and start applying the dye. So that's number 3. Oops. Number 3, you're going to apply the dye. Step 3. Apply the dye. So the dye molecules themselves, so like this is an example of one of the dye molecules. You don't have to draw that, obviously, but it's called Procian Brilliant Red. And we'll have a brilliant red back there tomorrow. But they have little ions, little hydrogen ions and hydroxide ions that stick up. And they're going to stick onto the hydrogen ions of the cellulose molecules. Okay? So the dye molecules have ions that will stick to the hydrogens and they'll form a bond. And we call this a hydrogen bond. They will form a hydrogen bond with the cellulose molecule. Now, that hydrogen bond, do you remember, did we say that a hydrogen bond is an example of an intramolecular force or an intermolecular force?
I don't know. I can't remember.
Yeah, it's inter. And the reason why we say it's inter because it's molecule to molecule. Yeah, and intra is like the ones within, like covalent bonding, ionic bonding, metallic bonding, okay? So this is known as an intermolecular force because you're hooking one molecule to another molecule with a hydrogen bond. So what happens is this little hydroxide, this little OH group right here, is going to come along and find this cellulose molecule. And this chunk right here is one individual cellulose molecule, okay? And see these little hydrogen ions that are just kind of sticking out here, all those little hydrogens. What's going to happen is this OH group is going to come along because it's got unshared electron pairs there that are ready to bond, and you don't see them, but you got 2 pairs of unshared pairs of electrons. You're gonna come along and find a hydrogen and bond, form a hydrogen bond. They're gonna be super attracted to that hydrogen. And every one of those hydrogens can hook one of those color molecules, okay? So you wanna make sure you give your shirt plenty of dye so that it will tie-dye all of it, and we'll talk more about that tomorrow. But you don't wanna overkill it, right? I've got kids that will just stand there and waste dye on a shirt that's already completely colored. Once you know that your shirt's got enough dye, stop, okay? Don't continue to drench it, because all of that excess is just gonna get rinsed off later. It's not like it's gonna magically be able to find more bonds. Like, it's only got so many spots. So once you see that you've got it covered with color, or as much color as you want, stop. All right. Okay. So the excess dye is going to get rinsed off later on. Is everybody good? Can I go? All right. All right. Then step 4, we're going to let it react for 12 to 24 hours. Let it react for 12 to 24 hours. Now, let me ask you this. So what we were talking about with the hydrogen bonding, is that an example of a physical or a chemical change?
What?
Like, whenever you apply the color to the shirt, is that a physical or a chemical change? It is chemical. It's a chemical change because you've changed the shirt on a molecular level, okay? And you would have to unchange it, you would have to put it through some other physical process. If we didn't like our tie-dye shirt, what's another chemical process that you can think of that could probably reverse it? Bleach, right? And so the kids at home, the virtual students, are going to be given the opportunity to do like a bleach tie-dye version, to where they'll take like a dark shirt or a dark piece of clothing, and you could do the same kind of thing to where you put it in a pattern. You don't necessarily have to pre-soak that shirt, but you would then use bleach to spray on whatever parts you want bleached, and then you let it sit for a little while, and then you rinse it out and do it just like you normally would. But bleach works in reverse. Instead of forming new bonds, it breaks color bonds. It breaks things apart. So bleach can go into a shirt, which is why, like, if you accidentally bleach, your favorite red shirt, it's going to come out with white spots all over it. Okay, because it goes in there, it breaks apart molecules instead of building them. So they're kind of doing the reverse process. All right, so we're going to let that react, though, for 12 to 24 hours. Why do you suppose that we're going to give it that long? Yeah, there's a lot. And you got to give it time to find and create strong bonds. And I know I said weak hydrogen bonds. Like, they're weak in terms of out of the intermolecular forces. They're weak compared to like covalent and ionic, but they're pretty strong as far as they're going to keep the color on your shirt. So in other words, when you take it home and you go to wash it next week, after you've worn it 3 or 4 times in a row, right? That's what everybody does. No, just me. Okay. So if you go to wash that shirt next week, you probably throw it in just a normal laundry, and the color won't bleed out onto everything else or it shouldn't. Okay. I wouldn't try it with your favorite white t-shirt, okay, the first couple of times. But now I've got some tie-dye shirts that I could throw in with my white laundry, and it's not going to hurt anything, because those molecules get set in there and they really do get bonded, and they're very hard to break. Okay, so we want to give it time to form good chemical bonds. The last thing that we'll do, so Wednesday morning when we come in, and I know that some of you have testing, and that's okay. The rest of us that are here, we're going to finish up the process. Okay? Wednesday morning, the excess dye is going to be rinsed away in the sink first with water. So we're going to cut it off all those rubber bands. We're going to rinse out the shirt in the sink, and then we're going to take it to the washing machine. We got several washing machines here at school. We'll take that, and we're going to put in something called Centrapol, which is like detergent, but it's known as a dye carrying agent, which means that I could take everybody's shirt in third hour, put it into all one washing machine. And if you do happen to have excess dye in your shirt, Gabe's shirt is not going to damage Haley's shirt because of the Centerpol. The Centerpol will be in the water and it will go in and grab all of those excess dye molecules so that your shirt won't back stain somebody else's. Like if you just wanted blue and gray on your shirt, hopefully, somebody else's red won't get onto your shirt. Okay? So that's the plan, though. That's how that's going to work tomorrow. And again, if you're at home, the alternative will be to do the bleach tie-dye, which I'll post instructions and a video for doing that. Okay? All right. So let me get out of this real quick, and then we'll continue to discuss some things.